Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.4, Problem 5. This is Section 2.4, Problem number 5. It says multiply the matrices, and you have two larger matrices. The first one has 1, 1, 2 across the top row, 0, negative 2, 1 in the middle row, and 0, 4, 0 in the bottom row, and you want to multiply that times the second matrix, which has negative 1, positive 1, 2 in the top row, negative 3, 0, 5 in the middle row, and 2, 1, 0 in the bottom row. So the first thing you want to do is see if these matrices can be multiplied, if there is an answer. So again, to do that, you want to verify that the number of columns in the first matrix is equal to the number of rows in the second matrix. And again, the way to do that is to write the dimensions of each matrix underneath. The first one is a 3 by 3 matrix because it has 3 rows and 3 columns. And the second is also a 3 by 3 matrix because it also has 3 rows and 3 columns. And if you check the inner numbers, they do match. They're both 3. So I know there is an answer, and the outer numbers of the dimensions tell me that the answer will be a 3 by 3. So I know it will also have 3 rows and 3 columns. So let's start setting that up, and this is going to be a fairly big matrix. So again, I'm going to write a really big matrix with really big boxes where I'll write out all the work, and then when we're done, I'll just write just the numbers. So I'm going to make a matrix with 9 boxes because there will be 9 answers to find. And what we need to do is systematically multiply each row from the first matrix times each column of the second matrix and write those answers in where they go. So to start, I'll multiply the top row of the first matrix, 1, 1, 2, times the first column of the second matrix, negative 1, negative 3, positive 2. So when I do that, I'm going to multiply first times first, 1 times negative 1. And then plus middle times middle, which is 1 times negative 3, plus the last times the last, 2 times 2. And now when you do the work, first times first, 1 times negative 1 is negative 1. Middle times middle, 1 times negative 3 is negative 3. And last times last, 2 times 2 is 4. And then you're going to add those values, negative 1 minus 3 plus 4 together. And it winds up being 0 when you add those numbers together. So that's the first answer. And I multiplied the top row of the first matrix times the first column of the second matrix, and the result I got went in the top row and first column of the solution. So now the next box over, I'm going to get from multiplying the top row of the first matrix, 1, 1, 2, times the middle column of the second matrix, 1, 0, 1. So to do that work, first times first will be 1 times 1, plus middle times middle is 1 times 0, and then last times last will be 2 times 1. And when you do that work, first times first, 1 times 1 is 1. The middle times the middle, 1 times 0 is 0. And the last times the last, 2 times 1 is 2. And when you add those values together, 1 plus 0 plus 2, the answer you get is 3. And again, if what we did, we multiply the top row of the first matrix times the middle column of the second matrix, and the result we got went in the top row and middle column of our solution. So now the next box over in the top row of our answer is going to come from multiplying the top row of the first matrix, 1, 1, 2, times the last column of the second matrix, 2, 5, 0. So first times first will be 1 times 2. Plus middle times middle will be 1 times 5. And then plus last times last will be 2 times 0. And when you do that work, first times first, 1 times 2 is 2. Middle times middle, 1 times 5 is 5. And then last times last, 2 times 0 is 0. And when you add 2 plus 5 plus 0, the answer comes out to 7. And what we did, we multiplied the top row of the first matrix times the last column of the second matrix, and the result we got went in the top row and last column of the matrix. That's the solution. So now I'm going to come across the middle row of my solution by multiplying the middle row of the first matrix times each column of the second matrix. So to start that off, I'll multiply the middle row of the first matrix, 0, negative 2, 1, times the first column of the second matrix, negative 1, negative 3, 2. So first times first will be 0 times negative 1, plus second times second will be negative 2 times negative 3, and then plus last times last will be 1 times 2. And when you do that work, first times first, 0 times negative 1 is 0. Second times second, negative 2 times negative 3 is positive 6. And then last times last, 1 times 2 is 2. And then if you add those values, 0 plus 6 plus 2, it comes out to 8. And again, I multiplied the middle row of the first matrix times the first column rather of the second matrix, and the answer I got went in the middle row and first column. So now the next one over, I'm going to multiply middle row of the first times middle column of the second. So the middle row of the first matrix is 0, negative 2, 1, times the middle column of the second is 1, 0, 1. So now first times first will be 0 times 1. And plus middle times middle will be negative 2 times 0. And then last times last will be 1 times 1. And when you do that work, first times first, 0 times 1 is 0. The middle times the middle, negative 2 times 0 is 0 again. And then last times last, 1 times 1 is 1. And when you add those results, 0 plus 1, you get 1. And again, I multiplied the middle row of the first matrix times the middle column of the second matrix. The result I got went in the middle row and middle column of the solution. So now I'm going to do the middle row of the first matrix, 0, negative 2, 1, times the last column of the second matrix, 2, 5, 0. So the first times first is 0 times 2. And then plus the middle times the middle is negative 2 times positive 5. And then finally last times last is 1 times 0. And when you do that work out, 0 times 2 is 0, plus negative 2 times 5 is minus 10, plus 1 times 0 is 0. And when you add those results, 0 minus 10 plus 0, the answer you get is negative 10. And again, in terms of where we put it, we multiplied the middle row of the first matrix times the last column of the second matrix, and the result we got of negative 10 went in the middle row and last column of the solution. So now I have to fill out the bottom. I'm going to multiply the bottom row of the first matrix times each column of the second. So to start that off, I'm going to multiply the bottom row of the first matrix, 0, 4, 0, times the first column of the second matrix. Now as I do that, first times first will be 0 times negative 1, plus middle times middle will be 4 times negative 3, plus last times last will be 0 times 2. And when you do that work, first times first, 0 times negative 1 is 0, plus the middle times the middle, 4 times negative 3 is negative 12, and the last times the last, 0 times 2 is 0. And when you add 0 plus negative 12 plus 0, you get negative 12. And again, where that solution goes, if you Notice we multiply the bottom row of the first matrix times the first column of the second matrix, and the result of negative 12 goes in the bottom row and first column of the solution. So 2 more boxes to fill in my solution. I do the bottom row from the first matrix of 0, 4, 0 times the middle column of the second matrix, 1, 0, 1. And I can see by looking, because of the zeros, the whole answer is going to come out to 0. After a while, you don't have to write out as much as you do initially. First times first is 0 times 1, plus middle times middle will be 4 times 0, plus last times last is 0 times 1. And when you do that work, they're all zeros. First times first, 0 times 1 is 0. The middle times the middle, 4 times 0 is 0 again. And then the last times the last, 0 times 1 is another 0. And when you add those up, 0 plus 0 plus 0, it does come out to 0. And again, we multiply the bottom row of the first matrix times the middle column of the second matrix. The result we got went in the bottom row and middle column of the solution. And finally, one more value to work out. We're going to do bottom row of the first matrix, 0, 4, 0, times the last column of the second matrix, 2, 5, 0. So now when we multiply that out, we're going to do first times first is 0 times 2, plus middle times middle will be 4 times 5, plus finally last times last will be 0 times 0. And now when you multiply those values out, the first times the first, 0 times 2 is 0. The middle times the middle, 4 times 5 is 20, positive 20. And the last times the last, 0 times 0 is 0. And when you add up 0 plus 20 plus 0, you wind up with 20. And again, that answer came from multiplying the bottom row of the first matrix times the last column of the second matrix, and the result we got wound up in the bottom row and last column of the solution. So now this is the answer, but there's a lot of work written into it, and it's really not the best form to do it. So we can write just the answers we got. So off to the side here, I'm going to say equals, and I'm going to write a matrix with just the answers. So the top row from all my work next to it will be 0, 3, 7 in the top, and then 8, 1, negative 10 for the middle row. And finally, the bottom row will be negative 12, 0, and 20. And I'll put some brackets on that. And that's the final solution.